Hey, let's get the party going. Hi. Hi, everyone. Hope you have a good day so far. Um, Welcome to today's webinar. Today, we're going to explore ArcGIS GeoBIM. If you have any questions during the presentation, please type them into the question box of your GoToWebinar control panel, not in the chat panel. Also, a recorded version of this webinar will be available on our website and YouTube channel within a few days. You'll receive an email with the link that it's available. So today, your hosts are Nick and I from the Microdesk Enterprise Asset Management team. My name is Evelyn. I am Enterprise Asset Management Strategy Consultant. I have a background in civil engineering, construction management, architecture, building science, GIS, and data science. It's all derived from my passion for using technology to support digital transformation, integrated project delivery, and sustainability development. We have another host today, Nick. I'll let him introduce himself.
Yes, and I am Nick, your co-host for today's webinar, along with Eve. Great to be with all of you today. I am an EAM GIS analyst here with Microdesk. I have a background in ArcGIS Enterprise, GIS systems, cloud integrations, real-time GIS, dashboard analytics, construction management. Eve and I are happy to bring a view of GeoBIM today from the perspective of digital twins. And I'll pass it back to you, Eve.
Thank you, Nick. Yeah, technologies evolve every day, so we're happy to share with you what's the latest and greatest. Before jumping into the webinar, here's a brief introduction to Microdesk. So Microdesk was founded in 1994 as an Autodesk reseller with the simple mission of assisting the AECO industry to improve workflows and integrated project delivery technologies. We've grown to have 12 offices and 300 professionals worldwide. Our drive has been built upon Microdesk culture that revolves around transparency and encouragement, building upon globalization, urbanization, and sustainability, thus enable the integrated digital delivery for our clients worldwide. We hope to translate this culture into the services and product we provide and build for our built environment. We partner with our world leaders such as Esri, Autodesk, and IBM to utilize innovative technologies and methodologies to empower sustainable design and overcome local challenges. Our vision is to reduce the environmental impact of organization by helping the AECO industry to design, construct, and operate better and more efficiently by leveraging the full potential of the BIM, GIS, BDC, and asset management. We also provide purpose-built software to streamline project setup, management, modeling, and documentation in the BIM process. We offer BIMRX, ModelStream, and ARI to fill industry gaps throughout the digital transformation processes. So, today's agenda, we will firstly quickly recap our previous webinar regarding the GeoBIM. If this is the first time you heard about it or the new offering, welcome to look back our previous webinar. But we will kind of recap what is relevant to the AECO industry and why you should know about it. We then will focus on today's topic around the application for construction, along with the ArcGIS GeoBIM demonstration. Next, we will discuss how GeoBIM is the foundation to provide that connected environment for a digital twin to move towards a higher maturity level. We will then showcase some BIM and GIS integration capabilities to enable that connected environment. So let's dive into what is GeoBIM. It is self-explanatory by its name, GeoBIM, the integration of geospatial technologies and building information modeling. This integration becomes an integral part of the AECO industry that enables stakeholders across the industry value chain and project workflow to take advantage of the relevant skill of both GIS and BIM models. The integration of GIS and BIM creates a binding synergy between spatial, technical building, and real-time data attributes, providing much required seamless among different spatial and non-spatial data sets, which is the prerequisite for constructing a complex, connected, and sustainable infrastructure. It is a holistic approach to providing seamless collaboration, deeper understanding, and better decision making. The benefit of the integration include, but are not limited to, faster plan approval, improved coordination, reduced cycle time, reduced material use and construction cost, and also increase the project resiliency. Our previous webinar discussed GeoBIM's global demands, trends, and challenges. Today, we will focus on the construction side of the applications and why the integration is so important as a foundation of the digital twin. So let's take a closer look at the GeoBIM application for construction. The graphic captures and quantifies the major problems associated with the poor data interoperability in construction project. 80% of projects are overshoot their primary budget, 52% that require rework, 35% time spent on managing rework and handling conflict, 20% of the project were not complete on time. These numbers show an increasing need for the application for advanced digitization solutions that can facilitate a workflow, collaborative workflow, resulting in integrated digital system. This makes the integration of GIS and BIM no longer an option, but a necessity to deliver and manage project with a more holistic view so the project can be efficiently shared, managed, and accessed by different stakeholders. Why does the integration of BIM and GIS provide that holistic view? Let's take a closer look on each side. So the building environment is where we define what we build. It allows us to visualize the building and construction, perform clash detection with different stakeholders, provide a model-based cost estimation and construction sequencing to improve scheduling and cost. However, several essential geospatial contexts are missing to support building design and construction processes. On the other hand, GIS side, it has enriched geospatial information to support project site survey and selection, on-site resources, project feasibility analysis, and environmental impact assessment. The information helps us better understand what to build, as well as where and why to build it. However, it is a non-trivial task to bring that information to support the design and construction processes. Therefore, by integrating the two, we can capitalize on both of their capabilities and gain additional benefits to construct our built environment more efficiently and sustainably. The project team can design coordinates not just within the building boundary, but also within the geospatial context for improved design review, visualization, and exploration. Organization all the issues in a single managed platform to facilitate issue tracking and resolving. Understand and monitoring project status throughout an integrated performance dashboard, including issue locations, completion timelines, and distribution across the team. Owners can see the status of a built asset with up-to-date construction documents, models, and other asset information as is in native form. Other applications for construction efficiency including, but are not limited to, material logistic planning, blockchain material tracking, smart sensor technology integration for non-on-site safety monitoring, real-time construction progress tracking and monitoring, construction waste management, and more. So let's take a look at what ArcGIS GeoBIM can offer now. So if you are new to ArcGIS GeoBIM, it is one of the outcomes that Esri and Autodesk collaboration are aimed to provide a GIS and BIM integration platform. It provides a cloud-to-cloud connection between the Autodesk Construction Cloud and ArcGIS Online. Bring these two worlds together in a new, intuitive way. We've presented some of the functionalities and workflow in our previous webinar. Nick is going to demonstrate some of its current application for construction. So I'm going to switch my screen to Nick.
Okay, thank you, Eve. Just a moment while we switch over here. Okay, now that we've heard why GeoBIM is relevant to your construction project, let's see how to create a physical GeoBIM application through a GeoBIM project. Now, before we begin, I just want to recant the architecture a little bit that we're using when we think of GeoBIM. ArcGIS GeoBIM integrates ArcGIS Online with the Autodesk Construction Cloud or BIM 360 projects in an easy-to-use web-based experience where project teams can explore and collaborate on BIM projects in a geospatial context. For this demonstration, an ACC project has been connected to GeoBIM, making the file structure of that project available to the GeoBIM application for direct linking of documents to the physical building elements. Now, without any further delay, we'll switch right over to ACC. Starting out with ACC, we organize our project files and engineering documents in addition to creating and managing issues related to those project files within ACC. Very quickly, I'm just going to demonstrate how we can create issues within ACC. So if I go into my bridge model, for example, I can open up one of my spans or my approaches. And we have this check mark option here. This is where we would see all of the issues that are associated to this document within ACC. We also have this option over here, which allows us to create the issues by category within ACC. For example, if we chose a safety issue, we could zoom in and select a position for that issue, define the parameters, and then publish it. When we run our tools within GeoBIM, this issue would then be synced to the GeoBIM application. Backing out to the top level. Now, before we move on, keep in mind that ACC is one of the foundational elements of GeoBIM. What that means for owners is that steps taken setting up a project in ACC will set the stage for the use of that data over its life cycle, as well as across all integrations with that data. With that said, there are a few high-level best practices that should always be followed when organizing data within ACC. First, make sure that you are creating a project for each real-world construction activity. You want to avoid at all costs catch-all type projects where data can get confused, and this can open the door to outdated or bad data being applied to decision making. Use meaningful naming conventions and take the time to standardize your metadata. Have conventions that are standard across not only the project, but all projects within your organization. Use project templates as a tool to create and enforce these standards within ACC for your organization. Heading briefly back to our slideshow here, we see we have the same ACC dataset that has been imported into ArcGIS Pro for use through one of the BIM cloud connections. And then that same dataset is reflected in ArcGIS GeoBIM. I just wanted to show this to reiterate the importance of designing and organizing your data from the beginning, because it is extremely transportable across different environments at this point. with that, we'll move right on along to our GeoBIM application. So there are several things happening behind the scenes to create the integration between GeoBIM and ACC or BIM 360. When we open GeoBIM, the landing page of the GeoBIM application is here in front of you. We can see GeoBIM projects owned by myself, or we can explore those created and shared publicly. From this interface, we also have the option to create a new project. We could define a name and start configuring that project. To save time for today, I have a project pre-configured for us. So we'll filter to data owned by me and go into this demo project here. When configuring a new project, the first step is always connecting to your ACC account and defining the project or projects that you want your GeoBIM application to interact with. You can only connect to one account. However, you can connect to any number of projects within that account for a GeoBIM application. It's recommended that you use the minimum connection possible, however, for your intended purpose. Generally, when you're connecting to one ACC or BIM 360 project, that should be related to one GeoBIM application. So it's really a one-for-one connection. Otherwise, it is possible to step past these restrictions, though it will come with performance implications in the syncing of your project with the GeoBIM tools. Once we have connected our Autodesk account, we can move on to the tools page, you see on the header here. From this page, we have 3 tools that will sync a connection between your Autodesk account and your Esri hosted data. The first tool in the list, the Locate Engineering Documents, will search through your ACC or BIM 360 project and generate polygons representing the extents of your models. The second tool, Locate Issues, will again comb through your Autodesk connected project and find issues, assigning them to their proper location on or in relation to their assigned model. Issues can be created from ACC, BIM 360, or GeoBIM, and running this tool will sync the record from both sides bidirectionally. So I create an issue in GeoBIM, it will go to ACC or BIM 360, and vice versa. The third and final tool, Create BIM Project Boundaries, defines the parameters by which project boundaries are created based on locations of issues and engineering documents within your project. All 3 of these tools have settings associated with them to fine-tune the processing to the needs of your project. And we can also view the history of runs from this tab on the top to be able to see when our integration was last made current between our GeoBIM application and our ACC or BIM 360. Our process continues from the Links tab. Now from the Links tab here, our first step will be to define the scene that will be used. This scene is going to be something that would be pre-made and hosted within our ArcGIS Online organization for use within our intended GeoBIM application. So I'll go into my web scenes, choose that. Once we have defined the data set to be used, we can apply links based on link rules or individual selection. You can see from the side, link rules are going to be query-based application of rules where we're basically specifying a filter and then applying a connection to an engineering document based on that filter. And then link to features is going to allow us to connect to individual features within our ACC or BIM 360 account. From this point, once we create those links, and we'll see more of those links within the demonstration of the actual finished GeoBIM application, we're ready to configure apps within our project. There's two types of application that can be developed within the platform, those being issues dashboards and viewers. If we go over to our apps page, we'll see we have the option to create new viewers and create new issues dashboards. As of right now, we only have access to those two application types within the current release of GeoBIM. Your choice in one or the other is going to depend on the needs of your target audience and the intended use of your application. A GeoBIM project can contain any number of GeoBIM applications of these two types. We'll move right along to our finished application here. So a viewer application is going to consist of the three portlets that you see on the right side of this dashboard app, that being the map viewer, this links explorer, as well as the documents explorer. A viewer application provides a powerful yet simple GeoBIM experience where users can access many standard tools for manipulating 3D scene. These include the ability to search locations, change base maps, measure features, toggle layer visibility, bookmark views, and navigate throughout the scene. Most more advanced features of the map widget include building explorer, time slider options, as well as the ability to create issues directly within the application. So with that, we'll go right into what a few of these are and do. So the building explorer here can be used to isolate features based on the level to which those features belong in the building. You can also filter by construction phase or disciplines. And I'll just display that very quickly. So here we have a list of all of the levels within our buildings. Here we have the Civic Center architectural layer selected. If I select one layer, it will then reflect that. Could be slow to render right now, but it will reflect all elements on that layer within this Civic Center building right here. So we'll move on along because that's a bit slow right now. We also have the option to slice data within these layers. To do so, we would create a new slice, and you can manipulate this plane to be able to get the view of the interior of the building that's necessary for your purposes. You could have multiple slices at the same time, but that's that feature. We also have the time slider option. Now, this time slider allows you to view the progression of a project's temporal components. We can select from layers containing issues, schedules, and BIM projects to view changes in one or a combination of these items through time. If I hit the drop-down menu, you'll see we have some toggle boxes here. We can view issues over time and use that time slider to be able to view them. If I wanted to see the full range of my data, we could do that from here. We also have the ability to create a new issue within this interface. We would assign a location by clicking a point on the ground and then define the parameters of that issue to be placed and hit create. Again, once we run the GeoBIM tools previously mentioned, that would sync that issue back to ACC. When we select an element of a building, for example, this air handler here, we have this Add Links button. When we click that, it's going to bring us over to a view of our ACC file directory, where we can choose from all of the documentation that we have here to link back to this document. I have some pre-made links defined. For example, we have air handler spec sheets applied to this air handling unit. When we press the play button on that, we see that that air handling spec sheet is rendered in the Forge viewer. The same idea is true if we click on the MEP project document. It's going to bring up the Forge viewer of that model, and with time, it will dynamically zoom to that selection. As you can see there, Now the last portlet of this standard interface that you see here is the Documents Explorer. We can explore our documents, our issues, our BIM projects, and our schedules, all from this interface here. When we select one of these things, we'll be able to locate it on the map, as well as press the play button to bring up the Forge viewer of that model. Moving over to the GeoBIM, or the dashboard interface that we have here, we see representations of our issues are displayed in the dashboard application. The portlets are dynamic, and when selecting a component of the graphics, they will show the related data within the map, as well as dynamically change the other portlets to reflect the selection that you have made. The dashboard component is totally configurable. You'll actually have a separate ArcGIS dashboards file created when you create a issues dashboard. And you can go into that within your organization, and you can make edits to the symbology, add or delete portlets, as well as changing attributes that are being displayed within a given portlet. To display their dynamic nature, when I click on a selection here, it's going to update the other portlets to show me a view of what's represented in that segment of the pie slice that I've selected. And now one more feature that we have here is bookmarks. If we zoom into a bookmark of my eastbound main span here, we'll see that I was able to colorize this layer, BIM layer, based on SID priority repair information that was contained in the data for this bridge. We have green elements in okay condition, all the way down to red elements that are in need of immediate attention. We are not able to just colorize these elements. We can also link documents directly to the troubled elements. For example, here we have a picture linked in that, when pressing the play button, will bring up a linked in picture of the repair needing to be made. Here we see this cracked element. If I click on another element, I have yet another document attached to that, and we'll be able to dynamically file through these different photos of priority repairs by structuring our data before import into the GeoBIM applications. That concludes the first part of today's demo segment. And at this time, I'm going to pass the floor back to Eve to discuss GIS as the foundation for digital twins.
Thank you, Nick, for the wonderful demonstration. Let's give it some time. If you can see my screen now. Yeah, yep. Perfect. Yeah, he's just showing us some of the ArcGIS GeoBIM's capability now. There are more to come, and the integration's potential is exponential. Especially, GeoBIM is the foundation for digital twin. Why I'm saying that? Let's take a closer look. So Geospatial Media recently established the GeoBIM maturity model, which is a coherent approach to map GeoBIM integration and use across the construction lifecycle. From initial convention models where BIM does not exist and there is no collaboration and integration, integrating GIS and BIM moves the maturity level up to a collaborative environment where information, whether it's a spatial or non-spatial information, is exchangeable between stakeholders, and a suitable information hierarchy is created, such as a common data environment for project coordination among various systems and project participants. The ultimate goal of the GIS and BIM integration is to provide that connected environment, which is foundation to continue to move the digital twin maturity ladder towards predictive and prescriptive twins, as on the show in the y-axis. So what Nick just demonstrated, it's already shows some connection that you can see what's in ACCs available readily in that GeoBIM platform as well as vice versa. So that being said, let's take a closer look at what is digital twin and why GeoBIM is an essential integration to move the digital twin maturity to its full. Digital twins are virtual representation of a real world including physical objects, processes, relationships, and behaviors. A digital twin is not a single product or solution. It is a complex network of technologies and systems. It must work in harmony to achieve the desired transformational outcomes and return on investment that the organizations desire. It is a dynamic digital reflection of that physical asset. That means it is bidirectionally connected and integrated to possess the operational and behavioral awareness necessary to simulate, predict, and inform decisions based on real-world conditions and provide real-time feedback. In order to achieve the full potential of a digital twin, a maturity model that breaks down the data requirements and capabilities is presented here. The first stage, digital artifact, is the starting point of the digital twin journey to capture and aggregate all the relevant data to answer the question of what do we have. We can then move on to the second level, digital record, a prescriptive twin. This is where the data from the previous stage can be validated, processed, and connected to describe the built asset and help the stakeholders understand what happened. With connected data, we can then start incorporate data analytics and business logic to evaluate collected data to answer why did it happen. We can then further apply machine learning and deep learning to predict the future, confidently understand what will happen, and support what-if type scenarios. Then, eventually achieve an autonomous twin that can act on behalf of the occupants or the owner-operators to provide a self-tuning processing facility. So where is the GIS and BIM integration situated on this maturity model? As we shown here, a mature GeoBIM model provides a connected environment. So that's a foundation pushes the digital twin to level 2, a comprehensive descriptive twin. This is a non-skippable foundation to move towards higher maturity level and ultimately reach that autonomous twin. This is especially true when the project scale is outside a single building boundary, which is for almost every project, not to mention the organization, infrastructure, and city scale. A modern GIS is a powerful technology to represent a holistic digital twins in a spatial context. GIS allowed us to abstract and model everything, bring together many different information models. Organizations have been using GIS for decades to create digital representations of the environment that they're spatially diverse linear asset information models. But as some business requirements have been involved, so many other complexities of these information models. A modern comprehensive GIS connects these disparate information models together. The land-based information model, for example, consists of the layer of environment, topology, social, and landscape. A building information model provides an accurate and highly detailed representation of structures, plans, and facilities. The network information model manages the design and logic of networks. The city information model allows for bigger picture modeling at scale. This assists a workflow for urban planning, citizen management, engagement, and most recently, smart city and smart community initiatives. Integrating this information allows us to have a comprehensive digital record to move towards that analytic, predictive, and ultimately autonomous twin. After integrating this many complex system, it seems still a long way to go to reach that ultimate autonomous twin. However, we've come a long way to solve the most challenging problem regarding the data interoperability to enable that connected environment. So the next section, Nick will showcase the latest capabilities that Esri and Autodesk offer to connect the data between BIM and GIS. So let me switch back to Nick.
Okay, thank you, Eve. Let me just get my screen up and ready to go. Okay. So I just want to emphasize the workflow that we're referring to here when we are considering a GeoBIM application development process. We're taking a real-world structure or proposed development, and we're using Revit or Civil 3D to model it. Now, if that data is not assigned a location from the Autodesk side, it must then be georeferenced within ArcGIS Pro. Once we're at a point of having a model whose level of detail fulfills our need and whose location is defined, we can then package that layer and publish it as a scene layer package to be hosted in the GIS, where it can be dashboarded, integrated with GeoBIM, and much more. While it is possible to define the location of a model within the GIS, it is generally more accurate and requires less manipulation if this is done within the Revit or Civil 3D side. I just want to emphasize the fact that in creating a digital twin, the first step of the process is always going to be taking your real-world elements or design, creating a model for that, and then georeferencing it. Assigning that georeference location is the first step in basically allowing that document to be referenced according to what it's in relation to. So with that, we're going to move on to a few screen recordings of process that I have prepared for us. In the first screen recording that we have here, we'll see how this process is done from the perspective of Civil 3D. We start in this recording from a site plan that has a correctly positioned survey point. And we use the Map CS Assign tool to assign a coordinate system. This can be searched by name or well-known ID. And we assign that intended coordinate system. And then a map can be added to that project to verify that that element has been properly positioned.
Nick, you're not showing the.
Yep.
Are you showing the? Okay. Apologize.
Okay, so let me get out of my slideshow here. And we'll see how this is done from Civil 3D. So we have our referenced point there. We're using the Map CS Assign tool. We're selecting our map projection based on a search of well-known ID, assigning it, and then we're going to go ahead and add a map to our project, and it appears in the proper location. So that's our first workflow here from Civil 3D to be able to make that first connection between GIS and BIM data, which is going to be assigning that coordinate point and then the associated coordinate system. Next, we're going to see how to do this from Revit. Now, from the Revit side, we're going to first zoom into our survey point. Survey point has a default of 0, 0, 0 coordinates. We're going to unclip that. And we're going to find a point and use the specify coordinates at a point tool to define the real world coordinates at that footing point. And then in doing so, we reclip our survey point to preserve those coordinates. And now when we bring this document into our ArcGIS Pro application, it will be immediately properly georeferenced on the ground, and we might only need to make subtle updates and adjustments using the ArcGIS Pro tools to do so. So moving on, we're going to see a view from ArcGIS Pro. Now here I'm creating a new BIM cloud connection. We're assigning it a name. It's going to ask you to log into your ACC account. Once you do so, you're going to see on the right-hand side, we have a BIM cloud connection added to our catalog. And when we click on that, we have all of our documentation from ACC now available to us within that document. Now, one thing to keep in mind from the ACC perspective, I'll bring that up real quick, is that when I click into one of these files, you'll see that I have the project documents as well as PRJ files associated to them. These PRJ files are going to be read by that BIM cloud connection to be able to tell ArcGIS Pro where the coordinates of that project document should be located in real world space. If that PRJ document is missing, then the BIM project file will appear in your ArcGIS Pro imported at the origin of your map document, which will oftentimes show up way far away from where the actual building site is. So it's important to maintain these documents within your ACC. And one thing to note is you can use an Esri CAD PRJ naming convention. So if I named this as esricad.prj, we could get rid of all of the other PRJ files within this file directory. And when they're brought into ArcGIS Pro, they would all read off of the same projection document. And our last flow that I'm going to go through here is what we can do with our BIM data once it's georeferenced. So once we have that context of real world location, we're able to use our BIM documents in conjunction with Esri's 3D base maps. For example, we can use the OpenStreetMaps base map to add BIM layers and give context to a real city location and how that would look like from a line of sight perspective. So here I'm just going to wait for this recording to start over. You could see we're excluding a document from the OpenStreetMaps file to be able to replace our BIM document in that location. So we start out with a view of the New York City skyline. And we're going to zoom in on our site for redevelopment, right off of Battery Park here. And then we're able to select elements of that 3D layer to be able to exclude from the rendering. And then we would be able to take this layer, add our BIM document layer, and you would see your BIM document in the context of a realistic New York City skyline. One thing to note about this workflow is the fact that although you see the building elements as white in this view, you are able to colorize and symbolize those elements based on your 2D GIS layers. So you can add additional context to these documents if necessary as a more enticing 3D deliverable for your stakeholders. And with that, concludes our final presentation for today, and I will pass back to Eve for a bit of a conclusion here.
Thank you so much, Nick. Yeah, what Nick showed here is just some of the few BIM GIS connections that offer. And welcome to let us know if there's a specific area that you're interested in. Now you've seen some capabilities that ArcGIS GeoBIM offers for construction, as well as the integration of GIS and BIM to set up the foundation towards a higher digital twin maturity level. We welcome you to join the digital transformation journey with us. We're in an exciting era where all the technologies are starting to integrate and emerge to serve broader audience in more efficient, productive, and compliant way. We move towards a higher maturity model in a digital twin or a GeoBIM market. So you can learn more about ArcGIS GeoBIM via their website or reach out to us to request a demo for specific use cases that you're interested in. We also offer different digital twin solutions, workflows that tailor to your needs, existing workflow, and different computerized maintenance management systems, such as ARI for Data Dictionary Management System, ARI Oasis for Data and Model Health Check, as well as IBM Maximal Integration Workflow. So thank you so much for your participation. We're open to question now. Just to reiterate, if you have any other topics that you're interested in that you can we can include in our future webinar, please feel free to reach out to us.
Yep, and if you have any questions right now, please feel free to drop those in the chat and we can answer them on air in our last 10 minutes here.
I know the topic is so broad, like from early design all the way through owner operation management, and then just the integration between ArcGIS Pro to the BIM environment. It's also a lot of steps. So we haven't seen any questions so far, but like I said, you have our contact. Feel free to reach out to us if you have any further questions or feedback about what you might be interested in for your application. We're happy to help and support and answer your needs.
Okay, yeah, with that, I'm not seeing any questions in the chat either. I think we could probably wrap up for today.
Yeah, thank you so much, and then have a great rest of your days.
Okay, thank you all for joining us.